Hi everyone, it's Math with AUB. Frame based on first year mathematics. I have tried my best to narrow down my scope, narrow down my focus. I have selected some questions from factorial, permutation, combination, and probability. You can say permutation, combination, probability, and factorial. Question number one is an elegant question: n cube minus n. Express this into factorial expression. N cube minus n cube minus n. Write this one in factorial form. N common, n square minus 1. N common, n square minus 1. We can factor out n square minus 1 as n minus 1 and n plus 1. Knowing the fact that 1, 2, 3, 4, 5 either add 1 or subtract 1. That is the way to expand factorial. It is the smaller where n is greater than or equal to 2. It's smaller quantity, the next one and the next. Write in ascending order n minus 1 times n plus 1 factorial. Look at this. Smaller, greater than n minus 1, greater than n plus 1. Keep on adding 1. If we add 1 in n minus 1 factor n minus 1, we will get n the next term. Add 1 into it, we will get the next. It is fit for factorial, but for factorial we need n plus 1 and n minus 2, so on. Here prior to this is n minus 2. Let me write here in a good fashion: n plus 1, in the reverse fashion n minus 1, n minus 2, n minus 3, and so on. 3 dots, the standard dot to show continuity. 3, 2, 1. Now we have multiplied this quantity. We have to divide this quantity as well. 1, 2, 3, 4, dash, 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 up to n minus 3 into n minus 2. We have divided, we have multiplied as well as divided in order to write continuous form from 1 to n plus 1, from 1 to n plus 1, or from n plus 1 up till 1, in order to express n cube minus n in factorial. Now the numerator becomes n plus 1 factorial and the denominator is from 1 to n minus 2, that's our n minus 2 factorial. We have successfully expressed n cube minus n in factorial as n plus 1 factorial over n minus 2 factorial, n plus 1 factorial over n plus 2 factorial. If you open this up, you will get the same result, n cube minus n. Let's see. This one, there is n plus 1 factorial over n minus 2 factorial. 1, 2, 3, so on. Let me start from n minus 4, n minus 3, n minus 2, n minus 1, n and n plus 1 divided by 1, 2, 3, dash, 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 n minus 4, n minus 3 up to n minus 2. They are cancelled out. What remains? N minus 1 times n plus 1. Write n out, n minus 1, n plus 1, it is equal to n square minus 1. So it's equal to n cube minus n. So that is the way to express n cube minus n in factorial form, taking n common, factorizing n square minus 1 as n minus 1, n plus 1. Hunting out, that is the smaller quantity, first number smaller, then writing in ascending order, then hunt for the deficiency. Deficiency is, the next term will be prior to this n minus 2, prior to this n minus 3, prior to this n minus 4, prior to this n minus 5, and so on up to 1. So we have multiplied as well as divided by from n minus 2, n minus 3 up to 1. It is our n plus 1 factorial and n minus 2. We have successfully written n cube minus n in factorial form. Okay. Question number 2 is also based on factorial derivatively to give you good view of the factorial notation, how to express them in factorial, how to open factorial. Let's see and find out. Now it's very simple question for you to attempt n plus 3 factorial over n plus 1 factorial. Obviously, n is a positive quantity greater than 0, it is a greater quantity, it is a lesser quantity. Open up n plus 3 from in descending order, n plus 2, n plus 1, and n minus 1, n minus 2, n minus 3, dash 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 3 to 1. Overall divided by n plus 1, n minus 1, n minus 2, n minus 3, n minus 4, and so on, 3 to 1. Knowing the fact that either add 1, write in ascending order, or subtract 1, write in descending order. From n plus 1 factorial up to n plus 1 factorial cancelled out. What remains? N plus 3 times n plus 2. N plus 3 times n plus 2. That's our answer in that case. So this is our answer in that case. Moving towards next question. Mine favorite. Express, find the number of the diagonals, or I used to say along with this, find number of handshakes or number of matches played among the teams. Number of matches played or number of handshakes and number of diagonals. Their formulas are almost identical, but let me find number of diagonals of any closed figure. Number of diagonals is given by n minus 2 and C2 minus n, where n is number of sides. Where n is number of sides, and we know that two vertices are joined to make a diagonal. Subtracting n is the original sides of the figure cannot be the diagonals. Either this is a diagonal and this one is also diagonal. These original sides cannot be the diagonals. That's why we have excluded this n. Some writers in quantitative mathematics, they write, instead of this giving you complete background, they write direct notation in that fashion. N factorial over 2 factorial, n minus 2 factorial minus n. Slashing out, open this up, 1, 2, 3, there is n minus 4, n minus 3, n minus 2, n minus 1 up to n divided by 2 factorial means 1 into 2, n minus 2 factorial means 1, 2, 3, dash, 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 n minus 4, n minus 3, n minus 2, minus n. They are cancelled out. What remains? N times n minus 1 over 1 to the 2 minus n. Taking LCM, we have n square minus n minus 2n. So it is tantamount to n square minus 3n over 2. They write this direct formula. How to find number of diagonals? Instead of this formula, to give you good view, they write this formula, n square minus 3n over 2, or taking n common, n times n minus 3 over 2. They write direct this formula. From where comes or occurs these? That is the corollary of this one. That is the background. That is the main formula. That is the concept. From where comes or occurs these two quantities. Don't mug up this one. Just you should have clarity and total number. Two vertices to be joined to make a diagonal, and original sides cannot be the diagonals. Okay, cool. Now I am in a position to find the number of the diagonals when number of sides is equal to 10. When number of sides is equal to 12. Okay. Value of n is 12. 12 C2 minus 12. 12 factorial. Opening up the combination formula. 12 factorial, 12 minus 2 minus 12. 12 factorial means 1 into 2 into 3 dash 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 10, 11, 12. Overall, 2 factorial means 1 into 2. 12 minus 2, 10 factorial means 1 into 2 into 3 up to 9 into 10 minus 12. Up to 1 to 10 cancelled out. What remains? 11 times 12 over 2 minus 12. Open up. Applying table of 2 on 12, 6, 6, 11, the 66 minus 12. 66 minus 12, if I am not at fault, 54 is the answer. 4 and 5. Yes. 54 are the number of the diagonals in a figure having 12 sides. Having 12 sides. 54. Okay. Moving towards next question. That is, you should have clear idea about mutually disjoint and overlapping sets. Mutually disjoint and overlapping set. How to find the cardinal number of the two finite sets. The question is, if A and B are mutually disjoint, A and B are mutually disjoint. Look at this. Mutually disjoint means their intersection is equal to null set. Their intersection is equal to null set. Mostly, normally, generally, number of elements in A and B are given by number of elements in A plus number of elements in B minus subtracting, slashing out the common portion. That is normally that is the case. Question demands from us that mutually disjoint. Mutually disjoint means A, B, A intersection B is equal to null set. A intersection B is equal to null set. Means this portion is meaningless for us. This portion is meaningless for us. Then the number of elements in A and B, when A and B are mutually disjoints, are A plus B. They have no common portion. That's the answer. In case for probability, same formula is valid. Probability of A union B is equal to normally probability of A plus probability of B, slashing out the probability of common portion, overlapping portion A intersection B. But it is given to us they are mutually disjoint. They are mutually disjoint means they have nothing in common. It is meaningless. So probability of A union B is given by probability of A plus probability of B plus probability of B. That's our answer. The question demands from us that we should have fair idea. Mutually disjoint means no overlapping portion, no common portion. Their intersection is null set. For counting the numbers, it is meaningless because it is equal to 0, and it is also meaningless because common portion doesn't exist in case of mutually disjoint set. So our answer in that case is option number D, probability of A plus probability of B. Moving towards question number 5, based on probability, as I have already told you, I have narrowed down my script. I have selected questions from factorial, permutation and combination to give you good idea about this, then move on. Okay, if probability of B is 7 over 12, then what is the probability of B complement? B complement law. Complement law for any event, probability of B plus probability of B complement always is equal to 1. Probability of B, probability of B complement. If you unite them, they are exhaustive. Their union is equal to universal set. Their union is equal to, their sum is equal to universal set. Ground set, the total number of possibilities, the total sample space. So probability of B is given to us, it's 7 over 12. We are interested in finding probability of B complement. Now it's cool. Shift 7 over 12 on right hand side. We are in a position to find probability of B complement. That is 1 minus 7 over 12. Taking LCM, a walk in the park. 12 minus 7, it's equal to 5 over 12. 5 over 12. 5 over 12. 5 over 12. So that's our answer in that case. 5 over 12 is our answer in that case. Question number next. How many signals can be given with 3 different flags when any number of them can be taken? Flags with different colors. Flag with different colors, they are different. There are 3 flags. Total flags 3. We are asked to find total number of possibilities. We have free hand whether to take 1 flag, 2 or overall 3. So that is question of permutation because the color matters. In case of flags, while on traffic signal or on train signal, the light matters. The light matters. Red, green, yellow, they are different. They are different. That's why we are using probability permutation in that case. Taking one flag, might be taking two flags, might be taking all flags, because it is flexibility for us to take when any number of them may be used. Any number, either one, either two, either all. Solving for this, 3 factorial over 3 minus 1 factorial plus 3 factorial over 3 minus 2 factorial plus 3 factorial over 3 minus 3 factorial. 1 into 2 into 3, 3 minus 1, 2 factorial means 1 into 2, cancelled out, plus 3 factorial, sorry, let me expand. 1 into 2 into 3, 3 minus 2 means 1 factorial is 1. 3 factorial, 1 into 2 into 3 plus 3 minus 3 is 0 factorial. 0 factorial is equal to 1. So this is 3. That 2, 3 is 6, 1 factorial is 1 factorial, 1 into 2 into 3 it's all 6. 0 factorial is equal to 1. So 3 plus 6 plus 6. 15. 15. 15 possibilities are there for waving different colors of flag, whether to take 1, 2 or 3. It's given to us. We have free hand, whatever number of flags we can take. That is the total number of possibilities. Why we have used permutation? Because color of flags matters in case of traffic signals or rail signals. It's my tiny effort for you guys to give you good idea about factorial, permutation, combination, and a little bit about probability. Let's solve by itself next.